Black holes are cosmic juggernauts. They have more mass than 1 billion times that of our very own sun, and they can outweigh an entire galaxy. But what's even more incredible is all this mass is focused into an infinitely small volume of space. A piece of space that's singular and has no volume. These are truly, truly incredible objects, which makes you think, what would it be like to fall into a black hole? But first of all, what do we know about black holes? Well, they're so called because their gravitational pull is so strong that not even the fastest thing in the universe, light, can escape from them. This means they don't emit any light, so they appear pitch black. They're formed when massive stars come to the end of their life. There's no more radiation pressure pushing outwards, and the only thing left is gravitational forces pulling inwards, making the star more and more dense and compact until it forms a black hole. There's even supermassive black holes, which are huge black holes that center for most galaxies, but even scientists aren't really sure how these are formed. So what's the first thing you'd see when you got out of your spaceship in front of the black hole? Well, actually, you wouldn't see the physical boundaries of the black hole, because there aren't any. But all you would see was a giant void in space where the black hole was absorbing all the light from the stars and galaxies behind it. There'd just be a giant black patch of sky in front of you, looming over you. At this point, the pull from the black hole will start pulling you towards it if you left your spacecraft. With no more propulsion from your spacecraft, the only force on you would be from the black hole, so you start to fall in. But the pull of the black hole depends on your distance from it. So if you're parked really, really far away, you're not going to move towards it very quickly in the beginning. But as you get closer and closer, the pull will get stronger and you'll start falling towards it more quickly. In fact, if you park far enough away, you'll still be able to have enough speed to escape. But as you get closer and closer, there'll be a certain point where no matter how fast you go, you're always destined to fall in towards the black hole. Now the first thing you're going to go through is something called the photon sphere. This is an area around the black hole where light particles known as photons can orbit around the black hole, just as the Earth orbits around the Sun. Now this happens because the gravitational pull of the black hole here isn't strong enough to always pull in the light. But what can happen is if photons, light, approaches the black hole at the right speed and the right angle, they can get caught in orbits around the black hole. Now for you, this means that if you look outwards, you might be able to see photons that are emitted from the back of your very own head, which means for a short amount of time, you'll be able to see the back of your own head as you're falling into the black hole. Beyond the photon sphere, you'll reach something called the event horizon, and this is the point of no return. If you go within this boundary, you're not going to be able to escape from the black hole, however fast you travel. But you won't be able to see this physical boundary. You will notice some strange things happen to the world around you as you pass it, but you won't actually feel any different as you go through it. And beyond this point, there's no escape. You're destined to fall into the black hole. Now you might think that everything so far has been really fun. Imagine being able to see the back of your own head. But actually, sadly, you're not about to enjoy it that much. See, I told you before that the gravitational pull of the black hole depends on your distance from it. So let's assume that you're falling in feet first. That means that the gravitational pull from the black hole on your feet is much stronger than it is from your head. So what this is going to cause is for you to stretch out as the pull on your feet is much more than your head, and you're going to pull out into a long stream. But sadly, this isn't going to be like what it's like in the cartoons. You're not going to form a nice long stretched version of yourself. But actually it's just going to sort of tear you apart, which is nowhere near as nice. And in fact, you're just going to look like this small plasticine man as you're gravitationally stretched apart by the black hole. So it's not going to be as fun, and you're probably not going to survive the fall. But there is still one more thing left to do, and that's to reach the centre of the black hole. Eventually you, or an elongated version of you, will reach the centre of the black hole. A mass 1 billion times that of our very own sun, compressed into volume of space with no volume whatsoever. Your body mass will now be part of the black hole, destined to pull any more curious astronauts into the black hole. Eventually though, the theory says that even black holes will evaporate and they'll return all their matter to the universe. But sadly, it won't return it in the form of you, but just in random particles floating through space. Thank you very much for watching. I hope you enjoyed the video. Don't forget to like, subscribe, leave some comments, check me out on Twitter at UKAstroNut. Thank you very much for watching, and I'll see you guys soon.